In terms of priority, the stretch, shrink, or the deflection, they are the top priority, and then left, right, left, right, up, down is the second priority. So here, my parent function is f of x is equals to q root of x. Now, it says the vertical shrink by 1/3. That means my function will be multiplied by 1/3. This is 1/3 q root of x. Next, it says 3 units to the right. So that means it will be x minus 3. Whenever it is right, it will be negative here. So it's like x minus 3. This is my g function. Second part. So my parent function is f of x is equals to cube root of x. It says reflection over the x-axis. That means the vertical reflection. So negative will be multiplied from the outside. So it's like negative cube root of x. Second thing, it says 2 units down. So if 2 units down, that means it will be subtracted 2 from the function. So negative 2. So this is my g of x. Next one. It says my parent function is f of x is equals to q root of x. Now, first it says horizontal stretch by a factor of 5. So by factor of 5, so we know with x it is opposite. So that means reciprocal of 5 is 1 over 5. So it will be like x over 5 because it's a horizontal stretch. So it will be divided. So x over 5. So that means my function will become q root of x over 5. That's the first thing. Second thing, it says translation of 4 units to the left. So now 4 units to the left, that means my x will become x plus 4 now. So x plus 4, everything remains the same. So like x plus 4 over 5. So that is my new function g of x. Since it is left, so that's why this thing is positive. The last one, let g be, okay, so the parent function is f of x equals to x cubed. G be a reflection in the y-axis. So y-axis, that means my x will become negative x. Just like negative x whole cube. Followed by a translation of 5 units up. So that means 5 will be added. So like negative x cube plus 5. So that is my new function. Okay, next one is a vertical stretch by 2. So that means my cube root function will multiply by 2 because of vertical stretch. Followed by translation of 4 down and 5 right. So that means it is 5 to the right. So that means it becomes x minus 5. And then it says 4 units down, so negative 4. Since it's down, it will be added outside. So this is my new function g. Next we say g be a horizontal shrink. Now say horizontal shrink, that means the number should be multiplied, which should be greater than 1. So if this is my, it will be cube root of x. So vertical shrink, that means if my f of x is equals to cube root of x, then 1 over reciprocal of 1 over 4 is 4. So my function will become 4x. So it's like 4x cube. Followed by a translation of 3 units to the right. So that means my x will become x minus 3 now, since it is moving 3 units to the right. Everything will remain unchanged. So 4 times x minus 3. When you distribute it, it will be 4x minus 12. So that is the, this is my g of x function. Okay, next one, 15.1. So my parent function is the cube root of x, f of x. It says reflection in the y-axis. If it is a reflection in the y-axis, that means left-right reflection. So my x will become negative x. So it's like cube root of negative x. Then it says translation 6 units down. If it is down, that means it will be added outside. That is negative 6. So this is my new function g of x is equals to negative x cube root minus 6. Question number 16. Let it be cube root of x. So it says vertical stretch by a factor of 3. Since the vertical stretch, I will multiply it outside. So cube root of x. Followed by translation of 3 units down. So 3 units down means 3 will be added outside and 4 units to the left. Units to the left, that means h will be negative. So it's like x plus 4. That is 4 units to the left. This is my transform function g of x. So this is, so always remember whenever we transform a function, so the sequence is like, first is the reflection, stretch or shrink. Second priority is of the translation. So always first to stretch, shrink, reflect, and then later on do the left, right, up, down. Okay, now here it says identify the transformation. Now see, this is my parent function, it's a root function. That's clearly like, it's only translation here, there is no stretch and shrink. So it's like +1, so that means 1 left, +8 minus 8 up. This one is the same thing, just okay, in terms of priority, first we should concentrate on stretch. So it's like vertical stretch by 2 because the number multiplied is 2. And since it is x minus 1, so that means 1 right. Okay. Next is 21. Okay, now there are a lot of things here. So first we'll concentrate on reflection and stretch. Now there is a reflection. Since negative is multiplied outside, that means it's the reflection over the x-axis. So reflection over x-axis. It's up-down reflection. Next is -1 is added. That means it is going down 1 unit. So down 1 unit. So first it is reflected over the x-axis, vertical reflection, and then it will move 1 unit to the 1 inch down. Next one, this one. Here also there is no stretch, shrink, and reflection. So only the translation. So +4, that means 4 to the left. -5 means 5 down. Now here, negative is multiplied inside. That means my f of x becomes f of -x. That means it is reflection over the y-axis. Reflection over y-axis. That means it's left-right reflection. Function like this, it will become like this. Second thing is, oh, there is a number multiplied 1/4 outside. That means it's the vertical shrink because it is multiplied outside. So vertical shrink by 1/4. Next is this one. So here, if you look at this one, it's a vertical shrink. So vertical shrink by 1/3. And then +6 is added, so 6 up. That is 24. 25 here, I think there's a lot of things, translation also and stretching also. So it's 2 is multiplied outside. So we'll say 2 vertical stretch by 2. Vertical is stretch by 2. Vertical stretch by 2. Now, the terms of transformation. So it is 5 to the left and 4 down. Okay, the last one is a negative is multiplied inside. So it's everything has to do with the horizontal. Now, since it is multiplied by a number which is greater than 1, so it's a horizontal shrink by 1/32. There's a negative also multiplied, so that means it's a reflection over y-axis. Y-axis means left-right reflection. Okay, or horizontal reflection, you can say. Okay, now here I have to identify the word. So what kind of transformation is this? Okay, now this is my parent function. For parent function is center is here. The center is shifted otherwise. So because the parent function is something like this. It goes like this. Right. At least 1 is the coordinates. For parent function, 0 is the center, or you can call it point of inflection. And one of the coordinate is 1, 1. Let's look at each of them. So first one is P. So the center of the P is 4, 5. Okay, when you move, when you move 1 up and 1 right, so as in parent function also, if you move 1 up and 1 right, so you reach 1, 1. Here also you move 1 up and 1 right, so you reach the same spot like 1. That means there is no stretching or shrink. It's only translation. So my function would be like cube root of x. It is moved like 4 units to the right. So x minus 4, it is moved 7 units up, so plus 7. The green one, q. So this is my p. Okay, that's the green one. Now here the center is moved again. There is like if you go one up and one right, reach the same spot. One one. The other coordinate is 1 comma 1 here in the parent function. It will also move like uh, 3. Center is moved to right and 3 up. So q function would be um, 3 to 2 to the right, x minus 2 and 3 up, so plus 3. Again, if it's in the parent function, there is a point called 1 comma 1. So 1 comma 1, if you 1 comma 1, if you move it 2 and 3, 2 units right and 3 up, you'll get 3 comma 4. So clearly you can see this is 3 comma 4. So there is no stretching or shrinking. It's only pure translation. Okay, next thing is R. Now in R also there is no let's say the center of R is moved to this part, like it's only one to the left. So my function would be like x plus 1. There is no up down, so x plus 1. Now see, in the parent function, one of the coordinates was 1 comma 1. So if I moved it 1 to the left, so negative 1 comma 0, the coordinate will become 0 comma 1. But clearly you see this is 0 comma 1. So there is no stretch and shrink, it's only translation. So that was R, and the last one is S. In S also, it's like moved 4 units to the left and 4 units down. So the function would be like 4 units to the left, so x plus 4, and 4 units down, so negative 4. If you take 1 comma 1 point in the parent function, if you moved it 4 to the left and 4 down, so it'll reach like negative 3 and negative 3. See here, this is negative 3 and negative 3. So it's only left, right, and no stretch and shrink. Now here also, if you look at this point, this is 1 comma 1 and this is 0 comma 0. Okay, now this center is shifted. Center is shifted like 6 units, 8 units to the right and 5 units to the down. So function would be like y is equals to cube root of x minus 8 and then 5 units down, so negative 5. Now if you want to check for stretch and shrink, so 1 comma 1 is the parent function, point on the parent function. Now move it 8 to the right and 5 down. So it will be like 181 plus 8 is 9 and 1 negative 4. But check this coordinate. Is just 9 negative 4? Yes. So there is no stretch and shrink. It's only pure translation. Look at this function. So your center is shifted here, right? So center is shifted like 8 units to the right and 5 units up. So my function would be like under root of cube root of x minus 8 and then plus 5. Now, if you want to check for stretch and shrink, so just this is parent function 1 comma 1. Now, if I move this 8 unit to the right and 5 units up, so the new coordinate would be 9 and 1 plus 5, 6, 9 comma 6. So this is 9 comma 6, right? So it's only translation, no stretch and shrink. So the center is shifted to this point, which is x plus 6, 6 to the left and 8 up plus 8. About this one, so here also it is like center is shifted to this point, which is 5 to the right and 8 to 8 up. So it's like x minus 5 because it's moving to the right and then 8 up plus 8. Okay, now you write the equation of the following function. Okay, now see here, if you look at this function, this is same. In the parent function also, if you draw it something like this is also same, 1 comma 1. So this ratio is not changing. That means there is no stretch and shrink. It's only pure translation. So center is moved till here, which is like 2 units to the right. So it's like cube root of minus 2 because 2 right and down 4, so negative 4. And here's, no, here there's something different. It's look like a reflection. The center is shifted. So center is shifted here, right? So center is shifted like two to the left and one up. So my function will be like, let's do something like this. So my function is like y is equals to a. Let's put a. Okay, inside x plus 2 and plus 1. Okay, let's check for this point, negative 10 comma 3. It lies on the plane. So that means when x is negative 10, y should be 3. So let's put it like y 3 is like a negative 10 plus 2 cube root 2 plus 1. So 3 is equals to a. 2 minus 8 is negative 8. So negative 8 cube root would be negative 2 plus 1. So it's like 3 minus 1 is 3 minus 1 is equals to a times negative 2. So 2 is equals to negative 2a. So a is equals to negative 1. So a is negative. So function is like negative under root of x plus 2 plus 1. Okay, now here, so we have to find function which is like, now see the transformation is 1 to the right and 3 up. So 1 right and 3 up. So this is a parent function. So 1 right and 3 up. So center is move 1 right and 3 up. So this is 1 right and 3 up. But this function is like it's moved 1 left and 3 down. And this function is like it has moved 3 to the left and 1 down, 3 to the left and 1 down. And here also this is center and this is center of this function. So center moved 3 units to the right and 1 unit to the up. Okay, here it says negative 2 cube root of x minus 1. So this is the parent function. So like how to identify the graph. Now see, the center is moved, like it doesn't move horizontally left to right. It has moved like 1 to the 1 down. Okay. So the first graph is reflected. So looking at this function, the function is first reflected over the x-axis. Okay, vertical reflection. And then it is multiplied by 2. So all the y coordinate is multiplied by 2. That means if this is my function, so that means if my coordinate is 0, comma 0, which is the original coordinate. So when I reflect it over the x-axis, I multiply by 2. So that means my coordinate will again be 0, comma 0. And then when I move it 1 to the 1 down, so it will be like 0, comma negative 1. So my new center would be 0, comma negative 1. Now let's check whose center is 0, comma negative 1. It has center of 0, comma negative 1. It doesn't have a 0, comma negative 1. It also doesn't have, it has also 0, comma negative 1. So this could be possible. And this has 0, comma. So these two are out. Now out of these two. So we'll take one more point. Right? Example 1, comma 1 is in the parent function. So 1, comma 1. If you like stretch it 2 times, so to like vertical stretch it 2 times, that means x shouldn't be multiplied. So y will be like 0, 1, x will remain 1, and y will become negative 2. Then again, you move it 1 unit to the down, so to like 1, comma negative 3. Let's check which graph has 1, comma negative 3 as a point. So 1, comma negative 3. See, this is the 1, comma negative 3. It doesn't have 1, comma negative 3. So this is your answer. So you can use 2 points to check your answers. Okay, so let's rewrite this equation something like this: 2 times x minus 2. Now, it's 2 times the multiply. That means it's a horizontal shrink by 1/2. So horizontal shrink by 1/2 x. That means x will be multiplied by 1/2. The second thing is it will move 2 to the right. So plus 2 to the x and 0 to the y. So if my center is 0, comma 0, and if I stretch it 1/2, so it will be 0, comma 0 only, because multiplying x by 1/2 doesn't change anything. Now plus 2 is added. That means x is added to it become 2, comma 0. No changes in y. So my center will now be 2, comma 0. So which of the graph has center 2, comma 0? This has a 2, comma 0 center. This it doesn't have. This also have a 2, comma. This doesn't have. This also doesn't have 2, comma 0s. Yeah, this have 2, comma 0 center. So it could be first and D. Let's take one more point. The 1, comma 1 is in the parent function. So horizontally shrink it by 1/2, that means x coordinate will be multiplied by 1/2. So 1/2 comma 1, no changes in the y. Then I have to move it 2 to the right. So 1/2 plus 2 is 3, 2.5, which is 5/2. And y will remain unchanged. So 2.5 comma 1. So 1 comma 1 will become 2.5 comma 1. So this is 2.5 comma 1, right? If you check this one, it's not 2.5 comma 1. 2.5 comma 1. So it's not this. So it's this one. Okay, now look at this function. This is a vertical stretch by -3. So that means whatever is a coordinate, first the y coordinate will be multiplied by -3. Then it is moved 1 unit to the left. So that means x will be added with -1 and 2 units down. So y will be added to -2. That means if your center is 0, 0, that means you multiply y by -3, that means it becomes 0, 0. Now, if you move it 1 to the left, so it will be 0, -1 is -1. 0 minus 2 is -2. So this will be your new center. So new center is -1, -2. So which one of them has -1, -2 as center? Only this one. This doesn't have this center is this one, so it's also not. This center is okay. Now let's check for one more point. Let's take 1, 1. 1, 1 is on the parent function. So if I vertically stretch it by 3 times, so it will become 1, -3. Now again, if I move it like 1 to the left, so 1 will become 0 and 0, -5. So 0, -5 should also be on the graph. See here 0, -5 is in the graph. That means this is the solution. Okay, in this one, here it says vertical stretch by a factor of 4. So that means whatever is my coordinate, my y will be multiplied by 4. After that, there is a horizontal stretch because it's 1/3. So let's rewrite this function something like this. 4. Let's bring it 1, 3 outside. So it will be like 6. Um, 6 plus 1. Because when you distribute it inside, so it will be 1/3 of x -2. So now, so first is a vertical stretch. Then whatever you get the new coordinate, then do it a horizontal stretch also by 3. So x will be multiplied by 3x. Then whatever you got the new coordinate as, then it will be moving 6 to the right and 1 up. So that you will get the final coordinate. Let's check for the center. Our center is 0, 0. When I multiplied my y by 4, it will remain 0, 0, no changing. And when I again multiplied x by 3, it will be same 0, 0. Now, when I move it 6 to the right and 1 up, so the coordinate will be 6, 1. So my new center will be 6, 1. Now let's check which graph has center 6, 1. This is center. It is not 6, 1, so this is out. This is 6 and 1. So this is center 6, 1. So it could be. This center is out. This center is okay. So only one of the function has 6, 1 as center. Let's check for one more point. Like let's take 1, 1. It is on the parent function. So 4 times y. So y multiplied by 4 will become 1, 4. Now x multiplied by 3 will become 1 times 3 is 3, 4. Now, if I move it like 3 units, 6 units, right? So 3 plus 6 would become 9 and 4 plus 1 will become 5. 4 plus 1, 5. So 9, 5 should also be on the graph. So 9, 5. So this is also on the graph 9, 5. So this is our solution. In this one function, first identify the transformation. So 2 is multiplied outside. So that means whatever is your coordinate, x, y will be multiplied by 2. Okay. Then it says x become -x. That means it's a reflection over the y-axis. So that means whatever is your x, it becomes -x. Then it's move 1 to the right. So no changes with the x, it will go y, will go 1 down. Okay, now let's check like take example 0, comma 0. Now when you multiply y by 2, 0 multiplied by 2 is nothing, so 0. And when you multiply 0 by negative 1, so it won't change anything, so it will be remain 0, comma 0. Now, there is no changes with the x, so x will remain 0, and y is moving 1 down, so it will be negative 1. So 0, comma negative 1 is your new center. This one has 0, comma negative 1 as center. It doesn't have this is center, so it's out. Its center is something like 0, comma negative 1. So this could be the answer. The first and second is possible. Then this is again 0, comma negative 1 at the center. So this could also be the function. So these three are in. Okay, now what to do? Let's take one more point. Let's take 1, comma 1. So if my 1, comma 1 is on the parent function, so multiplying y by 2 will become 1, comma 2. Then multiply x by negative 1. So that means it will become negative 1 and 2. Now, there's no change with the x, and so y will be 2, y will be go 1 down, so 2 minus 1 is 1. So negative 1, comma 1 will be on the point. So this will be 1, comma negative 1, comma 1. Let's check which graph has negative 1, comma 1. It doesn't have negative 1, comma 1. Yeah, this has negative 1, comma 1. So this could be. And this also, it also doesn't have. So this is our solution. Now, if you don't get the 2 points, then take one more point. Okay, let's take like negative 1, comma 1 also. You'll get this answer. Okay, now this one, you have to match. Now let's start with the easiest one. This one, q of x, is just 1 to the left and 2 down. So 1 to the left and 2 down. So 1 left and 2 down. Which graph I move 1 left and 2 down. So this is like not 1 left. This is not 1 left. This is not 1 left. This is 1 left and 2 down. So this is q of x. Next one, this one. It's like y multiplied by 2 and moving 1 up. So that means if 1, comma 1 is my parent function, or let's check for the center. First check the center. Center comma 0, comma 0 first, y multiplied by 2, that means it will remain 0, comma 0. Then is 1 up. So y is 1 up, so 0, comma 1. So 0, comma 1 will be my center. So this has a 0, comma 1 as a center. None of them has. Let's take one more point. If 1, comma 1 is on the function, so 1, comma 1. So if I multiply by 2, y should become 1, comma 2. And then 1 add 1 to the y. So it 1, comma 3. So 1, comma 3 will be on the graph also. So 1, comma will be 1, comma 3. This is the answer. So this is my actually P of x. Okay, now for this one, let's take S of x. Now it is vertically stretched by 2, 3 to the left, and 1 to the down. So that means if my center is 0, comma 0, it is vertically stretched by 2. That means y is multiplied by 2. So it becomes 0, comma 0. Then it's 3 to the left. So x is negative 3 added and 1 down. So my center will be like negative 3, negative 1. So new center would be negative 3, negative 1. This has negative 3, negative 1 as a center. Let's take one more point. If 1, comma 1 is my parent function, multiply by y by 2. So it's become 1, comma 2. Then 3 units down, 3 units left and 1 units down. So 1 minus 3 is negative 2. 2 minus 1 is 1. So negative 2, comma 1 should also be on the graph. So negative 2, comma 1. So negative 3, negative 1. Sorry, yeah, negative 3, negative 1. And 1, comma 2. 1, negative 2, comma 1. Negative 2, comma 1 is also on the graph. So this is S of x. Find the last one. Now let's identify, see the transformation. So this is actually not in the form that we are looking for. So let's rewrite this, like bring negative half outside. So it will be like x plus, it should be 3, right? So it should be negative 6, I guess, right? When I'm distributed plus 3. So now it's a reflection over the y-axis and 6 units to the right. There is no, now it's a horizontal stretch by 2. We have to reciprocate it for horizontal. horizontal stretch by 2, and then reflection over the y-axis. So if 0, comma 0 is the parent function, then multiply the x by negative 2. So it will remain 0, comma 0. Then 6 to the right. It will become plus 6, comma 0. No changes the y. So it will become 6, comma 0. Next, let's take one more point. So center is 6, comma 0. Let's take one more point. So negative 2x multiplied by x by negative 2. So it will become negative 2, comma 1. Next thing is like plus 6, comma 0. That means it will move 6 to the right. So negative 2 plus 6 will become 4. And 1 plus 0 will become 1. So 4, comma 1 will also be on the graph. So 4, comma 1 is also on the graph. That means this is R of x. That is how we identify transformation from the graph.